Hello everyone, I'm Salar and this is part 12 from my tutorial, and in this tutorial I want to complete the topic of Gnu Make. In Gnu Make we got familiar with some subjects, for example variables, automatic variables, creating a make file, writing your make file, writing rules, and a lot of other things. But in this part I want to talk about some other things, and mainly about functions. And before that, let's see a project that I want to use. Here in my home directory, I have a project folder. If you open that, I have a project that in my project I have a source directory. In source directory I have a function for multiplying, a function for dividing like before, and my main function, but let's delete this part. Okay, and a main function for printing, multiply and divide. Okay, and I have a header directory, and in this directory I have a header file. Here is the definition of my function multiply and divide, and I have another directory object. I want to put my object files in this directory when compiling code. Okay, when compiling code I want to put my object file to these directories, and I have a make file. In my make file I have a variable from my objects. In object directory I will have 3 object files. Okay, main, multiply and divide. That one we pass for a pass and a directory for searching source files, .c files, a rule for creating output from my object files, and I used automatic variable, and a pattern rule for creating my object file from my C file. Okay, I have this G file. This is for debugging, and I can delete that. Okay, a pattern rule that find my C files, and another prerequisite, my header file, and put my object files in object directory. Okay, in object directory with the same name of my C file. Okay, and then clean target and clean rule, that is a funny target. Okay, so I want to use function, but what's functions? Okay, what's functions? Functions like variable. The syntax of writing functions is like variable with $sign. We have some predefined or built-in functions. Okay, built-in or predefined functions, that is standard in Gnu Make, and we can define some user-defined function or custom function, but I will not talk about user-defined function in this part, and I just study about built-in function in this part. Okay, but what's the syntax of function? Like variable, the syntax of functions is $sign, name of your function. Okay, name of your function, a white space, and some argument. You can have just one argument or more than arguments that spread and split it by comma. Okay, and I can put the return value of my function, for example, in a variable. Okay, with recursive or simply expanded variables. The expanding rules of function is like variables, and I will not talk about expanding of function because I completely talk about expanding variables, and function is similar to variables. Okay, you can put the return value of your function in a variable. Okay, but let's use some functions, some built-in, and introduce some built-in functions. Before that, let's open this directory in my terminal. I'm in home directory and project, and let's make my project. If I make my project, I have output, and this is my output. But let's open my make file. As you can see in my make file, I have a variable here, object, and in my variable I have some object files. But before I make and compile my project, I don't have these files. Okay, I don't have these files. Now I compiled my project, so I have some object file in this directory. But if I if I run make clean and another time open GUI, I don't have any object file here. Okay, I don't have any object file here, and I need these object files, and I should put those for prerequisites of this rule, and make need these object files, name of these object files, for creating dependency chart. But sometimes I need to, for example, add another source file in my source, for example, another source file here. But I should make sure to add the name of the object file for those source files that I add to this list. Okay, and if I forget to add another object file when add a source file to my project to this variable, I should have some problem in my compiling. Okay, so how can I create this object files, this list of object files automatically by makefile? Okay, automatically by makefile. And when I add a source file to this directory, makefile automatically add an object file to this variable. Okay, how can I do that? Let's use functions for this purpose. Okay, let's use function for this purpose. I have a function that it's wildcard. Okay, what's the first function that I want to introduce? It's wildcard. What's wildcard functions, and what's the argument of this function, and what's the return value of this function? The argument of this function is a pattern to find some file in my directories. Okay, some file in my directories. For example, if I write source and star.c, it will find all of my C files in source directory. Okay, if I want that, it will find all of my C files in the source directory. Or for example, if I write, for example, header star.h, it will find all of my header file in header directory. I can write just, for example, star.c file, and it will find the C files in the working directory. Okay, for example, here working directory is project, and I don't have any C file in this directory. Okay, and I can, for example, put return value of my wildcard function in variable. For example, I can write wildcard source star.c, and it will list all of my source files in this variable. Let's do that. And for example, right here, I have a variable that value of my variable is a function. Okay, what's my function? Wildcard. It's a function, and what's the argument? Source star.c. Okay, you should have star. Sorry, you should use a star here, and I can create another funny target. For example, test and to print a value of variable. For example, print sources. Okay, and this is funny target, the test target, and funny target for printing the variable, the value of source. Okay, I can have this variable in simply expanded mode, but I don't want to talk about simply or recursive expanding for functions because it's similar to variables, and we talked about variables and expanding a lot in last and before part. Okay, so let's just save that and run, for example, make test. As you can see, echo source multiply.c, source main.c, and in source divide.c. List of my C files in source directory. Okay, in source directory I have 3 C files. So with wildcard I can define some files with a specific pattern. Okay, here .c files. And how can I print the variable, the value of my variable with some functions? Okay, as you can see, I define another rule here for printing. But how can I print the value of my variable with a function? In the before and last part, I talked about info function. Info is another function that when you write text, for example, hello, in the argument of this function, info will print this argument to the standard output. Okay, to the standard output, and I can, for example, put this function here, but not just in recipes. Okay, if I save that and make, for example, another time test, I will have hello. It will print all of time your string, because your info function is not in one of recipes and in one of rules. And when make run your code, all of time will print your info. But there is a difference, for example, between info and other functions, for example, wildcard. When you expand wildcard, the return value of functions, your functions, is a list of source file and you can put it variable. But for example, you can't have this instance. Okay, you can't have this instance because the return value of this function is null. Okay, is null. You have nothing when you expand this function. But when you expand this function, meanwhile of your expanding, just info write this text in standard output, for example, here in your terminal. Okay, but the return value of this function is null. For example, after this function, the value of variable is nothing. Okay, so you can't have this for, you can write this line in your makefile, but info will not put anything in your variable. Okay, but for example, in wildcard you can have this line because the return value of wildcard is a string. Okay, so use info just for printing some text and some string, not put some variable in your value in your variable. Okay, so I can use info here for printing the value of sources. Okay, for printing the value of sources here, and I can delete test. Okay, and I can delete test, and I don't need test anymore. Okay, and this time I will have my source list in source variable. After that, print the value of sources in output. Okay, let's save that another time. For example, make clean. I will have list of my source files that printed by info. That's printed by info. Another time, for example, make my project, and first of my make file. Another time, list of my source file. Because printing function is here first of your make file, and make will print this line every time. Okay, it's not, for example, in one of recipe, it's in first of your make file. So let's talk about another built-in functions in makefile. We have another function that it is, let's split that. We have another function, and this is function for substitution. Okay, substitution. What's the means of substitution? Replace a part of your string with another string. What's the format? It has 3 arguments, from, to, and text. You can have in text a variable like info or like other functions. Okay, let's give an instance. For example, you have substitute and you want replace ll with capital LL in, for example, hello. It will replace this LL, okay, this LL by capital LL, from LL to LL in your string, and return the value of function. And the return value, what's the return value? Hello. Okay, let's test that. For example, another variable var equal to return value of substitution function. Okay, and what's the arguments? For example, ll to ll, capital LL in, for example, hello. Okay, and let's print the value of my variable info var. I can add another string to this argument. For example, I can see the value of var is value of var. Okay, and let's save that and run my make file. Another time, for example, make says make is up to date, but because my info function is before of my rules, make will print this line all of the times. Okay, the first line my source files from my wildcard, and after that the value of var is hello with capital L. Okay, with capital L. And this is the output of my function, just hello. But this is the line that I wrote in info functions. Here, the value of var is value of var. But let's delete that and talk about another function. I want to create this variable, okay, this string, but I just have list of my source file. How can I convert my source file, list of my source files, to this list? I have, for example, a list of, for example, source main.c. How can I convert this string, for example, to object main.o? I can use another function in make. Okay, I can use another function in make. But what's the function? It's another substitution function, but pattern substitute function. And what's the argument? First, pattern, and the next is replacement, and the last, the text that you want to replace a part. Okay, but let's give an instance. For example, I want to substitute a pattern. So what's the pattern? For example, here I have this pattern, source, $sign and .c, all of my C files in source directory. And what's the replacement? For example, I want to replace these models with object $sign and .o. So it will convert, for example, source main.c to object main.o. Okay, and what's the last argument? The text that you want. For example, here the value of sources variable. Okay, I have sources variable, and it's all of my C files in source directory that separated by space. Okay, let's do that. As you can see, I want to convert this string to another string, and I want to use pattern substitute function. So let's do another time. Open my make file, and what's in this time? What's the value of object It's the expanding value of pattern substitute function. What's the pattern? Source slash %sign and C. Okay. What's the replacement pattern? Object slash, and after that %sign and that's O. For example, a %sign is main, multiply or divide. Okay. After that, in the sources variable, and after that I can print the value of object. Objects. Okay. So let's run that. So in this time, the object value comes from this function. Okay, this function, and the value of source comes from this function. Let's save that, make clean. As you can see, the list of my source file is source multiply.c, source main.c, and source divide.c. But the list of my object files in object directory mul.o, main.o, and divide.o. As you can see, I don't have my object files here. Okay, I don't have my object files here. But with some functions, I create the list of my object file before creating that, because for creating a dependency chart by Make, I need this list. Okay, I don't have them in my directory, but I need the name of these objects. Okay, so I can create those by functions. Okay, another time, make my project. This is list of my source file, this is list of my object files, and this is my compile process. And I can run my output. My output is true with the list of object files that created by make function. In this time, if you can see, I have my object files in my object directory, main.o, divide.o, and multiply.o. So I can do a lot of things by my functions. And let's see the Gnu Make documentation another time in this part. Gnu Make documentation. As you can see in manual of and documentation of Gnu Make, in the table of content you have a section for function for transforming text. Okay, in this part and in this section you have a lot of functions. You can write functions here, or for example with curly brackets. Okay, with curly, but I used parentheses. Okay, you can use curly bracket for functions and for example substitute function, a pattern substitute function, and a lot of other functions. You can study about these functions, and it's so easy. For example, word list and a lot other functions. Okay, for example with this function directory name, you can split just the directory part of your argument. Okay, for example here with this function, it will return the source, the directory part of this argument, and directory part of this, and its point, and slash means this directory. Okay, means work directory. And you can study about other functions in this section of documentation, and I recommend you to study this part, and you will have a lot of functions for using a lot of things in your make file and make your make file much easier. Okay, for example, here, if I add another source file in this directory, make will add another specific object files here, okay, automatically with this function. So for another example and instance, what happened if I have another source directory? For example, let's create another directory, and for example, its name is sources source2. Okay, source2. It's another directory, and let's do move, for example, divide to this source file. Okay, I have, for example, 2 subdirectory for source, and if I want to automatically find my source file and create a list of my object file with make file functions, I can use this way. For example, I can define another variable for my source directories, and its value, for example, is source and source2. Okay, source and source2, and search for C files in, for example, source directories, not just in source. Okay, so how can I list my source files in source directory? In source variable sources. Okay, with wildcard I can, for example, search for C source files in source directory. After that, append some other source file to my sources variable with append operator. Okay, with append operator. And another time with wildcard search for sources in source2. Okay, with this trick and this way I can search for all of my sources in all of my directories. And if another time, make file, and another time source directories, and what's my source directories? Source and sourced. Okay, and I should put the value of source directories here. Okay, after that, first search for source, and after that sources, and append another string to that, wildcard source2 and star.c. Okay, another time let's do make clean. As you can see, I can find my divide.c in source2 directory. Okay, but main.c and null.c in source1. Okay, but I have a problem here. I should repair my creating object files. Okay, repair my creating object files because the pattern of this part is not source slash. Okay, it's source to a slash. And in this time I should have some problem. How can I resolve this problem? Okay, how can I resolve this problem and create my object files, list of my object files in a true way? It's wrong, it's not object file. How can I resolve my problem? If I want to resolve that, let's do open makefile. I should run another time this function, but another time with another pattern. Okay, with another pattern. For example, another time. Now let's do copy that and paste it here. One time for source and one time for source 2. Okay, another time for source 2. Let's do, and I should repeat my function. Okay, I should repeat my function, but another time change objects. Okay, change objects. Okay, let's do first change those files that in source file. After that, change other that in source 2 files. And let's save that and run another time. For example, make clean. What's the problem? Source recursive variable object reference itself. Oh, sorry, recursive variable reference itself. Let's do split my screen. Okay, as you can see, if I have recursively variable here, this time I should use variable for expanded, and it's not true. Okay, so I should have here and simply expanded variables. Okay, and simply expanded variables here, because the rules of expanding functions like variables, and you can reference a variable in itself when you have recursively expanded variables. And if another time save my make file and run, for example, make clean, I will have a list of my variable. Here is source to divide.c, but I have object.divide, object_divide.o. Okay, and if run my make file, I will have my output. It's the list of my source file in source directory and source 2 directory, and it's the list of my object files, and I can have my output. Okay, so as you can see, I should repeat my using function here. Okay, repeat 2 times wildcard and 2 times pattern substitute for creating my object file. So how can I use another functions for repeating some works in makefile? Okay, for example, you have for or while in your C and C++ programming, and you can use that and use those statements for repeating some actions. And you have a function in makefile and Gnu Make that you can use that, which you can use for repeating some actions. Okay, repeating some actions. So let's talk about that. Let's do close and clear my screen. So let's describe it here. I have it for each function. Okay, for each function in Gnu Make. For each. Let's write it better. For each function, and it has 3 arguments: var, list, and text. So what's these arguments? Let's describe those by an instance. Okay, for example, for creating list of my source files, I will have this function. For each directory in list of your source directories, use wildcard function and find those functions that start with this variable, and in those that C files. Okay, those that C files. So what's these functions and what is for each? For each, first separated value of that is in this variable and separated by a white space. Okay, for example, in source directories I have 2 values that's separated by a space. First is source after source 2. Okay, I have two separated by a space variable value in my variable source. First directory equal to source and do this function. So what's the output of this function? In the source directory, first search in source directory. Here is source. Okay, here is source first. What's the output? main.c and mul.c. As you can see in source, main.c and mul.c. First, repeat this function with another variable, another directory. So another time, directory equal to source2 and do another time this function. So the output of this function when the div is source2. What's that? Search in source2 for C files is div.c. div.c. In source2 I have div.c for divide. After that, concatenate all of these values and put in a variable, for example var. So after that, concatenate all of these and var equal main.c, mul.c and div.c. Okay, so first pick each of word which separated by a space. Each of word first. Each of word separated by a space. Okay, in make file you have 2 words separated by a space, source and source2, from source directories, from the list of your variables. After that, put each of separated value to this variable. After that, run this function with this variable. Okay, the third part, run this text with this variable, and the last part, concatenate all of your values to each other and put in your variables. Okay, let's use that in my make file. Let's do write it here. For example, I want to create my source list by for each. Okay, for each function. Let's to close it. So first, define a variable. After that, source list a variable that you want. Okay, a variable that you want to separate each of word. Okay, here is source directories. Okay, after that, my wildcard function. My wildcard function. Okay, so use this variable in that. Okay, use directory in that directory and find all of your C files. Okay, all of your C files. So the source is now is all of my C files with for each function. Let's save that and run make clean. It's the list of my source file with for each function like before. And after that, list of my object files. If I run my make, I will have my output. Okay, so how can I use for each function for creating my object files? For creating my object files. Let's do that like here. Like here, I want to create my objects. Before that, let's do create, for example, an object 2. Okay, I don't want first delete this file, these lines. Okay, but after this example, I will delete these lines and replace object 2 for my objects. Okay, so I want to use for each function. For each function. Okay, for each function. First, like before, I want to use this file, sorry, use these variables, these values for using pattern substitute. Now one time source and another time source, another time directory from list of my source directories. Okay, and I want to use a pattern substitute function. If I want to use a pattern substitute function, I should use pattern substitute here. Okay, I can in make file split my line in some lines. Okay, split a line in some lines with slash and enter. Okay, if you want to split line to some lines, you should write and slash after that a new line. Okay, it's like a line. Okay, but I can use this. Okay, it's a way. I want to pattern substitute. What's the pattern? What's the pattern? Yeah, for example, first I want use this line. Use this line. Okay. Let's describe it here. Okay. What's function? Let's find my pen here. Okay, here is my pen. What's my function? For each directory from list of source directories, I want to run pattern substitute function. If I write that, for example, here, pattern substitute substitute, and let's write my pattern. For example, here those files, those values that start with dir, and the pattern is C file, replaced by object and that's O suffix from list of your sources. From list of your sources. Okay, let's do it. Right. This pattern here. Pattern that start with directory from list of your source directories and sorry, directory .c files. Okay, I have one here. Directory from C files. Here, after that, object. And replaced by O file from list of my sources. Okay, from list of my sources that created by this line. Okay, after that, let's do info objects 2. But I will have a rank. But what's the rank? Let's do run that. Save my file here and run my, for example, let's do now make clean, for example. I missed the close parenthesis. Nano make file, open parenthesis here, pattern as substitute, close that, from my C files, replaced by object. I think I should put a here. Okay, let's run that and make, for example, here. So there is a rank. I have object mol.o, object main.o source, and it's not true. It's not true. First, here, replace these two files. After that, replace just last file. Why? Because let's describe that. What is my directories? Let's do write it, for example, here. Or I have two value from source directories. First directory is source and run pattern substitute for that. For example, run this, for example, my function pattern substitute, and this is arguments. Source .c to object .o from all of my source. Okay, so for the first output, I will have object main.o object mul.o, and because the last is source2 div.c. For source2 I will have source main.c, because it's not in the pattern of source2. It's not pattern of source2. Source mul.c, but in this time object div.o, and concatenate all of these variables. So my output is here. Okay, concatenate all. So how can I resolve this problem? With pattern function. Okay, pattern function. What's the pattern function? For example, the name of function is filter pattern. Okay, two part. The name of function is two part. Filter white space pattern. After that, pattern of your files that you want to filter from a variable. For example, pattern source / and a C file from your sources. Okay, I should this function for resolve my problem. For example, here, despite of just write source to find all of your source files, I should use pattern. I should use, for example, filter pattern directory and person.c from your sources. Okay, I should all of this part instead of this part. So first, for pattern substitute, filter. For example, you want to create object file from source directory. Okay, first pattern those files that in source directory. After that, replace source by object and convert it to .o file. Okay, and another time repeat that for source too. So if I want to create this, I can, let's do split that in two lines, and instead of source I should write filter pattern. After that, pattern with your directory that you want. Okay, pattern that with your directory that you want. Pattern with those files that in directory and your C file that is in this directory. Okay, from now, from your sources. Okay, from your sources. It's a long function. You have call function nested. Okay, you can call function nested, for example. So here, save that, and another time run make, for example, clean. As you can see, object mul.o, object main.o, object divide.o, like it's object 2 and this is object. Okay, all of those objects, and here is true. Okay, and I can write my function in that splitted, and which is split in 2 lines or just in 1 line. Okay, just in 1 line. Save that, and another time, for example, write run clean, make clean, and another time run make. But let's do delete this line. I don't this line anymore, and my objects created by for each function. Okay, let's do save that, another time run make clean. This is the list of my source file, and this is the list of my object file, and make my project. Now it's my output. So as you can see, I can use function to create a lot of things. Okay, create a lot of things. Okay, here I use function to create my list of my object file and my source files. Okay, I can write complicated functions. Okay, I can use functions in complicated way. Here, creating my object files with for each, pattern substitute, and filter function. Okay, and filter function. But there is another important thing. For example, if you want to use expanding object, for example, here in prerequisites is immediate, but your function and your object is recursively expanded here. Okay, is recursively expanded, and you can write it in simply expand, but it's not important because make expand this part immediately don't care to type of your variable, and will expand your objects just in line. Okay, but it's important thing that you, for example, you want to use source directories here for vpass. Okay, here we're vpass, and you can, for example, put source directories here. Okay, you can't use that here. You can't say that sorry, you can't say that here is immediate and make will use these subdirectories here, because here your source directories is undefined. Okay, is undefined. So when you want to use a variable, you should put that here. You should define that here before using. Okay, define that before using. And for example, here I have another function. This is flavor. Let's use flavor function. What's flavor function? Flavor can use for specify the type of my variables. For example, I want to print the type of source directories here. If I write that here and save my file and run, for example, make another time, type of my variable is recursive. Okay, type of my variable is recursive. If change it to colon and equal, another time, make type of my variable is simple. Okay, simple, but if put this line put this line before defining variable. Let's cut that and put this line here. Okay, before defining source directories, and save my file and run another time. It's undefined. Okay, so be sure and make sure to define your variables before using. Okay, before using. It's a so important thing. I don't talk about expanding function and variables anymore, and you should use the before information about variable and expanding part 11 to find what's the recursive variable, what's the recursive function, expanding, and all of things. But there is a function that's its name is flavor, and it can be used for finding the type of your variable, or your variable is defined or undefined. So for example, when you want here use object, you should define object before this line. Okay, because here source directories is undefined, but after that is defined. And be sure to use the variables in a true way, not in a wrong way. And this was an introduction about Gnu Make. You will have another things in Makefile and Gnu Make documentation. For example, implicit rules. Okay. For example, implicit rules. What's implicit rules? Implicit rules is a rule that it doesn't have a recipe. Okay, and it's so important when you want, for example, programming for your computer, for example, for your Linux operating system, and when you want to programming for your computer, implicit rules is useful. But because we want to use Makefile and GCC for writing programs and some programs for microcontrollers, it's not so useful, and I don't pay my time for teaching implicit rules, and you can study implicit rules here. Or for example, other things, for example, suffix rules. Suffix rules, I can't find that here. Suffix rules is old-fashioned in Make, okay, in Gnu Make, and you can use pattern rule instead of suffix rules. And I have a recommendation for you to study about automatic dependency or prerequisites generation. Study yourself about this topic. It's a beautiful and useful topic, and I don't want to pay my time to teach that, and you can study about automatic dependency generation and prerequisite generations, and you can find it very useful in your Make files. Okay, and this was a brief introduction about Make files, and what's Make files, what's variables, what is rules, what's targets, what is pattern rules, what is functions, how can we use functions, and other things. And I know it's enough for Makefile, and you can increase your ability in Makefile by study documentation. Okay, here is my Makefile. And it's enough for introduction about Makefile, and in the next file I will start talking about debugging GCC and GDB, using GDB and GCC for debugging my source files. And thank you very much, and see you soon in the next part.